All right, in this video, I'm going to work through 5 problems on solving quadratic equations. These will be similar to what you would have seen in that first homework assignment called Solving Quadratic Equations Preview/Review. All right, now some of you just got out of Math 100 and worked on solving quadratics in Chapter 11, and so it's pretty fresh. Others are not coming right from Math 100. So you may need just to kind of remind yourself how you factor and how the quadratic formula works. So I just wanted to do a few problems, and then you'll see some additional problems on quadratics as well. All right, so this particular problem asked you to solve by factoring. Even if it hadn't, that should always be your first try, your first attempt. But anyway, there's a million different ways to factor, and you all are coming from a variety of teachers, so you may do it differently than I do. But by this time, at this level, you really should be moving towards just factoring by trial and error, factoring by just thinking about how binomials get multiplied and just unfoiling that. So you know that whatever goes in the first spot would have to give you the x squared. So that gives you the x and the x. Whatever's in the second spot has to multiply to be 14. And don't put in the signs to start with, would be one recommendation. You know 14 can be broken down as either 1 and 14 or 2 and 7. And then when you think about it, only 2 and 7 would give you any chance of making a 5 happen there in the middle. So what goes at the end has to multiply to be the 14, and then those wind up producing the middle term. You'd have a 2x and you'd have a 7x there in the middle, and that's where the negative 5x comes from. And so you'd need the 7 to be negative and the 2 to be positive. Now you put in the signs and do a quick check. Don't forget this. Don't forget to make sure that last number turns out to have the correct sign. So they are different signs, and that does give you the negative there at the end. Okay, now once you get to there, what happens is, since you have two numbers multiplied together equal to 0, you know you can set each of those factors equal to 0. And this is the amazing thing about factoring, is you went from having a quadratic squared to now having things to the first power. Okay, and you know everything there is to know about solving those. So you just subtract 2 from both sides, add 7 to both sides, and you wind up with x equaling negative 2 for one solution and x equaling positive 7 for the other. Okay, and it was squared. That's the degree right there. And that tells you how many solutions to expect. So we're expecting to get those 2 solutions. Okay. All right, now let me make a couple pages so I don't get caught. All right, so that's just a quick reminder of how to factor. And you don't have to do an extensive review of factoring, but you need to be able to factor when it's something easy to factor, especially when there's like an understood 1 right here. It's much faster than trying to jump in and use the quadratic formula. Okay. All right, so let's look at question number 2. All right, on that one, you're solving a problem that has a different form, only has 2 terms. It still is a squared though, still is quadratic. You could solve this one by factoring. Okay, so you could. I'm going to show it that way. Okay, but you could also use the square root method. Both of those would be good choices. I would not solve this one using the quadratic formula. Okay, if I'm going to solve it by factoring, I would take the 64c squared minus 25, and I would think about it as an 8c and an 8c, a 5 and a 5, with a plus on one of them and a minus on the other. Okay. All right, then I would set those factors. Oh, let me slow down there. I don't know why I did that so fast. I wanted to comment on the fact that this is a really fun thing to factor, because 64 and 25 are perfect squares. So when I noticed that makes it not, I don't even have any trial and error. if it's going to work, it's going to have to be an 8C and an 8C, a 5 and a 5. See, by doing that, the middle term turns out to be 40C minus 40C, turns out canceling out. Okay, so I'm going to set those equal to 0. And then I have two linear equations. I'm just going to finish solving. So on one of them, I'm going to subtract 5 from both sides. On the other, I'm going to add. So on one of them, I have 8C equals negative 5. On the other, 8C equals positive 5. Then I'm going to divide by 8. And I'm going to wind up with C equaling either negative 5/8 or C equaling positive 5/8. So I get those two solutions. Okay. All right, and that's solving it by factoring. That's what I would have done on that one, is to solve by factoring. The second I see those perfect squares and the fact I only have two terms, I kind of know it's one of those special types and I can factor it real quick. All right, and then some people might notice the squares and think, well, you know what? Let me take and move the 25 over by adding 25 to both sides. Okay, so I'm going to add 25. Okay, I'm going to stop showing all of those at this level. I don't think I have to show as much as I do in Math 100. Okay, and then I could square root at this point, but normally or sometimes that 64 may not be a perfect square. So it's good practice to get your squared part completely isolated. Get the C squared by itself. Okay, then you can come in and square root both sides. Okay. And the biggest mistake that students make is forgetting that there are two square roots to a number. So if you wind up doing the square root of both sides, that symbol really only means the positive one. So you have to be sure to put that plus or minus there, or you're going to miss one of the two solutions. So then I get C equals positive or negative square root of 25 over the square root of 64, which would be 5/8, positive or negative. Okay, let me write that a little better. So your final answer would be positive or negative 5/8. Okay, and you got to be sure to get both of those solutions. All right, so that's question number 2. Let me go ahead and jump to number 5 in your homework, because it's kind of related to that second method there. Number 5 was one that is best done using the square root property or square root method, because it's got this x plus 6 squared. And so if I can get this part isolated, what I'm going to do is just come in and take the square root of both sides. So the square root properties really works on ones where it's possible to isolate the squared part. Okay, like it wouldn't work on question number 1 because of that x being there on the middle term, because of this. This is why it wouldn't work. Okay, so you couldn't get the variable isolated, the squared part by itself. Okay, all right, but on this one, what we're going to do is divide by the 3. And so that's going to give us the squared part by itself equal to 20. Okay, so this is the place where I'm going to come in and square root both sides. Don't forget to take both the positive and the negative square root of 20. Okay. All right, so that's going to be x plus 6. Squaring and square rooting kind of undo each other. Over here, square root of 20. All right. And then I think I'm going to show it a little differently than I did during the class session. I want to add a negative 6 to both sides. And the best place to put it is right there. So it's not confusing about whether it's under the radical or not. Okay. So at this point, you're almost done, except 20 contains a perfect square. So you need to break that down. And if you notice the 4 times 5, you can stop right there and put the 2 outside. Some people have learned to go all the way to the prime factorization and to look for pairs of 2s. And then what's left? is the 5. 2 out in front and then 5 under the radical. So we're going to put that in place of the square root of 20. And make sure you don't put the plus or minus between the 2 and the square root of 5. It's in front of it. And then this would be your final answer. These are your two solutions. And you can't put them together. They're not like radicals. So you'd stop right there. Okay? All right, so that was using the square root method, doing the square root method, square root property. Okay? And that's what we used here on the alternative way of working number 2. Okay? But the most important thing that I want you to be able to do is use the quadratic formula. Okay? We're going to need it here at the start while we're doing systems of equations, and we're going to need it in our next unit when we do polynomials. In another unit when we do polynomials. The last step of every problem, when you're solving a polynomial, usually involves the quadratic formula. So really make sure you're understanding this. Okay, so first off, the quadratic formula you need to know it. It needs to be memorized. And there's videos out there you can watch to do that. I'll post one that you can use to remember that, but you need to know that backwards and forward. Okay, so the solutions to ax squared plus bx plus c equals 0. Okay. And that this part is just a technicality to force this to really have a square term, but you don't need to memorize that. Are given by the following formula. X equals negative b plus or minus square root of b squared minus 4ac, and then all of that over 2 times the a. Okay. All right, so let's go ahead and use that on question number 3 and question number 4. Okay, so on number 3, we're trying to solve 2x squared minus 9x minus 2 equals 0. And they told us to use the quadratic formula, but when it's left up to you, your plan should be to try to factor real quick. And if factoring doesn't work, then you use the quadratic formula. It's just this one wouldn't factor. Okay. Now, one of the things you got to do is identify correctly your A, your B, and your C. So A is 2. When you grab the B, make sure you pull the sign along with it. B is negative 9. C is also negative, has a negative in front of it. So C is negative 2. And make sure that your equation has been put in the form ax squared plus bx plus c equals 0. Make sure things are in that order and equal to 0. Okay, then you plug into the formula. Okay, so the formula says x equals, it has a built-in 2, built-in opposite. Okay, so we're going to put those numbers into the correct spots. All right, so we're going to do the opposite of b, and then this is also b in parentheses getting squared, minus 4 times a times c over 2 times a. Okay, so when you're showing your work to me, this right here is very important, so I can see that you plugged in the right stuff. And then you don't just go from there to the answer. You kind of work it through. Opposite of negative 9, 2 times 2. The negative 9 in parentheses squared would be positive 81. And then this is minus and this is negative. So that's going to be plus something. And we'll get 8 times 2, that's plus 16. Watch these signs right here. See, the negative 9 is in parentheses. So make sure you understand why that's always going to be positive in the beginning. And then here we had one negative, but then we had another negative. And a negative times a negative is why that turned out to be positive. And then 4 times 2 times 2. Okay, so we're to the point where we have 9 plus or minus 97 over 4. Okay, now normally at this point you would do some simplifying of the radical, but it turns out with 97, 1 and 97, but then 2 doesn't go into it, 3 doesn't go into it. I don't have to try any of the even ones since 2 didn't go into it. None of them work. So I'm just going to try some odd ones. 5 doesn't. Okay, 7 doesn't go in there. All right, and then I don't even need to try 9 because 3 doesn't, but you could have tried it. 9 doesn't work. 10 I don't need to try. I might try 11. Nope, 11 won't go into it. So once I get to there, I can pretty much stop because I would have got that's as far as I would need to go. When you get to around the square root of that number, you don't need to keep testing things. So this thing must be prime. 97 must be prime. So there's no way to break it down more. And this would be my final answer. Okay. All right. And then I just want to do one more on this video. Let's go ahead and look at question number 4. Okay. 4 is x squared minus 6x plus 45 equals 0. And the directions said to use the quadratic formula, but if you had tried to factor it, you wouldn't be able, you should think, well, let me give factoring a quick try. But if you tried, it wouldn't work because 45 is only 1 in 45, 3 in 15, or 5 in 9. And there's no way to make a middle term of 6 happen with those. Okay, so we're not going to try to factor. We're just going to identify our A, our B, and our C. We're going to go to the quadratic formula and plug those in. Okay, and then this a lot of times is the hardest part, the simplifying part. So let me really see you do that. Opposite of negative 6, 2 times 1, but don't cancel the 6 and the 2 and say 3 right now. Okay, work on the radical part. Negative 6 times itself is positive 36. Then you see how there's only one negative? So it'll just be minus something. And then 4 times 45, that's 180. Okay, so we're going to wind up with this equaling 6 plus or minus the square root of a negative 144 all over 2. All right, now, see that negative right there? Okay, that means we're going to have an imaginary number. We're going to get an I on this. So we're going to come over here with the square root of negative 144. And we already know we're going to have an I because that's giving us I. And then 144 turns out to be a perfect square, just 12. And so we have 6 plus or minus 12i all over 2. Okay. All right, and then since 6, 12, and 2 all have a common factor, you need to simplify this. See, 2 is a common factor on top. I can factor out a 2, and then I can cancel those. Normally, we just go from here to here. We just say 2 goes into 2 once, and it goes into each of these. And I get 3 plus or minus 6i. So whatever makes sense to you is okay. All right, so in this video, I just did a quick review of how to solve a quadratic equation by factoring or using the square root method or by using the quadratic formula. You really want to get good at using the quadratic formula, being accurate and being efficient with it. Okay, so let me stop sharing.